In this lesson, we're going to start on the second half of the unit, which has to do with systems of equations. So this lesson specifically is going to tie together a lot of different things you already know about equations as we head into the new material. So first off, it says the following are three one-variable equations. Solve for x algebraically in each equation. Now the first one, when we see the x equals 5, is actually already solved. So ultimately, when we're solving a one-variable equation, we're trying to get to that point. Here, there's no algebra we have to do, so that is the answer. On the next one, we see that the x isn't by itself, so we're going to get the x by itself on this one. When we look at this type of equation, we see that it's a linear equation. So I can just subtract 2 and divide by 3, and then we're going to get x equals 4. The next one is still a single variable, but now we see it's quadratic. So I know because there's 3 terms, I can't just move things over. I'm going to have to factor to solve this one or possibly use the quadratic formula. Factoring works here though, so I'm going to go with that. So numbers that add up to -5 and multiply to -14 are -7 and +2. So I get answers of 7 and -2. So this one's a little different. We have one variable and we had 2 answers for that one variable. So below it says when solving one variable equations, you are ultimately trying to manipulate the equation so that it looks like the equation in exercise 1A, solved for the variable. Sometimes, as in exercise 1C, there is more than one value of x, but you are still trying to manipulate the equation so that you have one or more x equals. So we're going to start to look at another type of equation. This is a 2-variable equation, and it says find the value of x and y in this equation. So let's just pick one. Let's say I'm going to solve for x. So if I try to get x by itself, I'm going to move the y over. I get 2x equals 14 minus 1y, and divide by 2. So I see that in this equation, I can't get the same clean x equals a number. And we also see that, let's say I picked the number 0 for y. So I plugged in a 0 for y. And that would give me 14 minus 0 divided by 2, so then x is 7. But let's say I picked a 1 for the y. So now I have 13 over 2, which is 6.5. So the idea here is I can't actually solve and say this is a value of x because it depends on what y is. And if I'd solved for y, I also can't find a definite value for y. If I just keep picking different numbers for x, the y will also change. So it says, as you can see, there are many or actually infinite pairs of values for x and y that make this equation too. So the pairs we found the pair when x is 7 and y is 0 could work. So this is, and I started with y the way I solved it, but typically we'd write the x and then the y. Here we saw that x was 6.5 and I plugged in a 1 for y. And if we kept going, we could find basically an infinite number of values for x and y. One equation is not enough to get that single value, or at least a finite number of values for x and y. So it says more variables, more equations, or the more variables we talk about, the more equations we see. So when we solve equations, basically if I see more variables, I'm going to need more equations to solve them. Looking at the next page, that's why we end up having systems of equations. Any systems of equations you guys have done are basically, at this point, 2 equations with 2 variables. So when I have 2 variables, I usually need 2 pieces of information or 2 statements about equality to know what those values are. And systems, you have seen work together in one or both of the following ways. They can share information with each other, we'll see, and they can also be added together to create new equations. So here we have our first system. We see we have x and y, and we should, because we have 2 equations, be able to find the exact values of x and y versus the infinite values when we have one equation with 2 variables. So here I have 3x minus y equals 2 and x equals 5. So here is an example of sharing information. This equation, the second equation, knows that the x value is 5. So they can communicate with the other equation and say, well, x is 5, so that means you can plug in a 5 for the x. And then from there you can solve. So we're going to subtract 15. We get y equals negative y equals negative 13, so y equals positive 13. So here, because the x has to be 5, the y ends up being 13. We can't have any other value for x other than 5 because of that second equation. So we have just this one answer. Now it looks like two answers, but really it's one answer with two different kinds of parts. So it's kind of like if I asked a question, what do you want to eat and where do you want to eat? And you said, I want to eat pizza at Slices. That's one answer. It has two pieces. It has a thing you want to eat and a location, like an X and a Y, but it's still just one answer. Different than on the other page when we had two numbers and they were both X's, that's two answers. So let's look at the next one. This next system, we see we have y equals 3x minus 2 and y equals 5x minus 4. So in this one, we're not given a definite value for either of these, but we do have information we can share with each other to work towards those values. So because both y values are given, or we're given something that's y is equal to, that means that these two have to be equal to each other. So this is 3x minus 2 equals 5x minus 4. And none of this so far is new. Really, none of this lesson is new. This is just kind of like bringing together the stuff you've done with equations so far. So from here, we can start to solve for x. Notice that by having the two equations communicate, now we're down to just one variable, which is x. So I'm going to add 4 over, so we get 2, positive 2. I'll write that just so we can see it. So positive 2 equals 2x. So if I divide by 2, x equals 1. So from this so far, we get that this is the only value of x because we solved here a one variable equation. Then we can take that value of x, we'll communicate back with one of the two equations. I am going to choose the first one, so I'll just write it down. And this equation can now tell us that the x value has to be 1. 3 times 1 is 1, 1 minus 2 is 1. So here, our answer, our one answer, is that the x has to be 1 and the y also has to be 1. We don't usually do this, but since we're kind of getting into the nitty-gritty of things, I just want to point out if I'd taken that 1 and plugged it into this equation, I would also get 1, and that's always true. As long as my first step was correct, those equations have already communicated, so no matter which one I pick, I'm going to get that 1, the y value that happens to be 1 in this case. So it says in the above system, the two equations shared information with each other. Both equations give information about what y equals, so they can be set equal to each other. After solving this equation for x, that information can be passed back into one of the original equations to find y.